Is the screen visible?
Yes, sir.
Yes, sir.
Okay. So before we start, tell me one thing. You read about dynamic programming in this week, right?
Yes, sir.
So what problems did you discuss in dynamic programming?
Sorry, sir. What was the question?
I mean, which problems did you discuss under dynamic programming? I think you discussed longest common subsequence and longest common word, right?
Yes, sir. And like grid paths and matrix multiplications. Those.
Okay, so you did not cover knapsack, right?
Sorry, knapsack.
Yeah, knapsack. I went through the lectures, but I did not find knapsack. So I'm just confirming, have you done this?
No, sir. We have. I think we haven't done this.
Yeah. So it is criminal to cover dynamic programming without a knapsack. So today we'll be covering knapsack. So there are two variants of knapsack. Uh, Give it a go. We'll probably end up explaining it anyway, but still. So this is the first problem, a 0-1 knapsack. So the problem is that you are given n items. Okay, so let's say you have 4 items. Every item has some weight and every item has some profit. Okay, that is a value. You have a bag which can carry a fixed amount of weight. That is, let's say in this example, you have 4 items and you are with a bag. Think about it as you are a thief. Okay, so you have a bag and you have entered a house, so you are planning to take away items. So you want to maximize your profit. That is, you want to take as many items as you can to fill up your bag, but you also want to maximize your profit. Okay, so that is the 0-1 knapsack problem. So see if you can solve it using dynamic programming. Let's take, I think, 15 minutes just to, I mean, don't code it up. See if you have an idea of how to do it. Coding is, I mean, that would be a step further. But if you are able to solve this, ping in the chat or maybe raise your hand, and we'll see afterwards.
Sir, can you explain it again?
Yeah, just a second. So you are a burglar, you are a thief, okay? So you have a bag with you, and your bag can only carry, let's say, 8 kgs. In this case, W is equal to 8. So anything greater than 8, you can't carry in your bag. So in the house, there are, let's say, 4 items. Every item has some weight and every item has some value. Let's say it is worth 1, 2, or 3 something in some denomination. Let's say 1 lakh, 2 lakh, and 5 lakh. Okay. So you have to decide which items should I take to maximize my profit. Okay, so you come up. So in this case, it is best to take item 1 and item 3. That is 0, 1. That is, take this item and take this item. So 3 plus 5 is 8. So you cannot take any more items. But with this, you get 2 plus 6 equal to 8. If you take up any other combination, you won't get the maximum profit. Let's say you took 4 and 6. 2 and 4, so your weight would be 6. It is less than 8, so you can carry that, but your profit would be 5 plus 1, 6, which is less than the optimal value. Do you understand now? Does anyone have any confusion with the question? Okay.
Sir, here what items define? What items used for?
Mm, an item can be anything. I mean, let's say a watch or something. Think of it like that. You have an item, it has some weight and some
No,
value.
no, no. I'm not asking about what item says, but what items define here. Like what the item one or three. What items actually shows. Uh, let us say a bag carries 8 kg and
Mm-hmm.
one item weight is 3 kg. So
Okay.
it only can be stored one time. So another item of 5 kg, 5 kgs were remaining in the bag. So we
Mm-hmm.
can also store an item one, only a
Mm-hmm.
single item of 5 kg in the bag.
Okay.
So why here the value of item for the weight of 5 kg is 3?
Oh, let's say the solution for this one, we said, okay, take item one, it has weight 3 and value 2, as you said, right? So we are left with a space 5, 8 minus 3, 5. So in that space, the best thing is to do this, that is take item 3, which has weight 5 and value 6. The net weight is 5 plus 3, 8, which is within the constraints, and the value is 2 plus 6, which is 8. Any confusion still?
Okay, means it's like an array weight. Weight or the value are in an array and zero index
Hmm.
shows the value
Yeah,
0.
exactly. Yeah. So this is a weight of item 0. This is value of item 0. This is weight of item 1, value of item 1. Yeah. Anos, do you have anything to say?
No, I got the answer.
Oh, you know how to do it.
Yeah,
Okay. So can you share it with the class?
I don't code right now, but
No, no. Just in theory. In theory, how would you do it?
first, according to the as you say, here the item shows the number like an array starting from the whole number, or we say starting from the zero, zero, one, two, three,
Mm-hmm.
four. So
Mm-hmm.
uh, we first get the list of item, uh, or we say length of item, and as an key in a dictionary, like
Mm-hmm.
we stored the value and weight together,
Mm-hmm.
and sorry, as an key we stored the item number 0, like and value is 2 and 1. So
Okay.
in the as an tuple, because
Mm-hmm.
it never be changed in the future, and
Okay.
uh, after it we apply an for loop, so that we take all the values in a list, uh, which a weight sum is 8, and after after it um, after it we find we search the weight in the list, in the
It
dictionary, sorry,
satisfies the condition. Mm-hmm.
in the dictionary, and it iterate it again for the highest value sum,
Okay. Okay.
and then
So
return it.
yeah. So if I understand your solution, you're saying that we will first find all possible combinations of these items that are within the constraint, that is less than 8. and then we will take the best one. Is that correct?
Yeah.
So how will we find all possible combinations? Let's say we have these 4 items. First, we take
We
all 4 at
basically
a time.
uh, we basically add, like we have a dictionary dict, and it's as an indexing it, as we index it 0, 1, 2, 3, and 4. So at for
Yeah, I
0.
understand that. I'm saying to find all the combinations, we basically first have to list them. So let's say we have 4 items. All possible subsets will be basically the supersets. So the superset will be 2 raised to the n. That is 2 to 4, 16. So
Yeah.
let's say instead of 4, I gave you a big number, let's say 100 items. So you will have 2 raised to 100 combinations, and you have to check each one of them. So your time complexity is exponential, 2 raised to n. And
Instead of
this solution,
let's
and
forget
this
about
solution,
uh,
hmm,
it instead of it, we only check, let us say we take 2, and all the combination, like here there are don't any other number than 3 or 5 make 8 kg weight, but like we have hundreds of them. So
hmm,
like 3 plus 5, or 2 plus 6 make 8 kg weights, or less than it. So
hmm.
corresponding uh, simultaneously with it, we check the value of it, what value it gives.
Yeah, but still we'll be checking everything, right? We don't know which combination will be the best. We will still check everything, right, in the end. And the thing is, we want to use dynamic programming. We are not using dynamic programming in your solution. What we will do will be very close to what you're saying, but your solution does not use previous experience. That is, if I have computed, let's say, the suitability of 234, then I should know the suitability of 2345. That is the essence of dynamic programming, that we utilize our past experience. We don't recompute everything. For example, in recursion, if something comes up again, we compute it again. In dynamic programming, if something comes again, we utilize our experience and just state the values in order one time. That's a good attempt. So does anyone else have any sorting list one, add combinations up to max 8? So that's again the same thing, like we have to find the combinations, and that won't use dynamic programming. So let me show you how to do it. Is the screen visible? Can you see an Excel sheet on your screen?
Yes.
Yeah, so whenever you do dynamic programming, you have to know that it will involve tables, either one table or multiple tables. Okay, so in dynamic programming, it is the solution itself is easy. How you frame the solution, that takes time. So how do we take the table and what will each cell of the table represent? So let's say we had, in our case, n equal to 4, n equal to 4. The weight was, max weight was 8, and these are the values and the weights. Okay, so we have the values and we have the weights. So we will create a table which will have n rows and W plus 1 columns. So what will that signify? Let's see. So let's say we have n rows. The rows will signify which item we are considering at the moment. So the 0th row will be item 0, then item 1, item 2, 3, and I think that's it, right? We had n equal to 4. So yeah, item 0, item 1, item 2, and item 3. So that is 4 items. And weight and along, so let's in fact right, like we have items, and then we will have weight. What we will store in weight is we will sequentially increase the size of the bag that we are holding at the moment. So the thief entered with a bag that had a max size of 8. Let's pretend that initially his bag has size 0, that is he can't carry anything. Next time we will consider that he has size 1 bag, then size 2 bag, 3, 4, 5, 6, 7, and 8. Now why are we doing it? We're basically in dynamic program, what we want to do is if he had a bag of, let's say, size 2, and we somehow knew what is the optimal value for this, does this help in predicting this? What would be the optimal value when we have a bag of size 3? Does anyone have a confusion up to this point? So the columns are weights, and the rows are items. Okay. Any confusion?
No, sir.
Okay. So after that, in the beginning, we say that we are considering item 0. So let's also write there, let's say we write there weights and values here so that we can input those. So let's say item 0 had weight 2, then it had value 1. Similarly, item 1 had weight 3, the next has 4, then the next has 5. And here we have 2, 5, and 6. Okay, so this is basically just item 0 has weight W, value 1, item 1 has weight W, value this. Okay, so let us keep this in a different shade, maybe. Yeah, so in the beginning, the thief has a bag of weight 0. Can he add item 0 into it? It has weight 2. He cannot. So what profit will he make? He will make 0 profit. Next time he has a bag of weight 1. Okay. Can he add item 0 to it? No, because it has weight 2. So again 0. Now he has a bag of weight 2. Can he add item 0 to it this time? Yes, he can add the item to it. Because he adds it, he will gain its value. So the value will be 1. Okay. In every subsequent weight, he will be able to add the item. So 1, 1, 1, 1, 1, and 1. Any confusion, anyone? Clear up to this point?
No.
Hmm?
Can you repeat this step once again?
Yeah, just a sec. So in basically row 0 signifies item 0. So we are checking, can the thief take item 0 or not? So the column signifies the current weight of the max weight that the thief can hold. So column 0 says I cannot hold anything. So can you add item 0? No, you cannot add item 0. Then we say, okay, my bag now can hold 1 kg. So can you add item 0? No, my item is 2 kgs. So I still cannot add it. In in this column, the max weight that I can hold is 2, and my item weighs 2. So I can add it. Once I add it, how much value will I get? I will get it equal to this, v equal to 1, because that is the value of item 0. So we get 1. Now, because I was able to add it in max weight 2, obviously I can add it in 3, 4, 5, 6, and 7, 8. Everything else will also be 1. Correct? Any confusion?
Awesome.
Okay. So we get to this point. Now, this is the initialization of the table. Next time we come around, we come to item 1. At item 1, we say, can you add item 1 to this bag? No, we cannot add it because we have weight 0. So nothing will be added. Then we come to weight 1. Can you add it here? No, because we have weight 3. So you will say 0. Now you have weight 2. in weight 2, you say, can you add this item? No, you cannot add the item, but you can add the previous item, right? Because it had weight 2, and you already know at this point here. So let's say we are in this column, we are considering item 1. If we find out that we cannot add the item to our bag, we don't have enough space, we should check in the previous row what was basically a column signifies the values for a particular max weight. If I cannot add the item, let me check what was the optimal value considering the previous items. So with the previous items, the max value was 1. So I will retain 1 because I will add item 0. Then I come here. Now the max weight is 3 that I can add, and I have two options. Should I add item 2 or I should add item 1? Now I have a choice, right? And I cannot add both of them at the same time because it will be 3 plus 2 equal to 5. So I have to choose the one with greater value. This one has greater value, so we add 2 here. Correct? Any confusion here? Right? Okay. So the next time we come up, we see that now the weight is 4. So the weight is 4. My item has weight 3. I can add it. So in this case, I again have to basically compare what would be the value. I mean, think about it. At this point, in the previous row, we had included item 0. My choice is, should I replace item 0 with item 1? So we basically compare what would be the value if I replace it and if I don't replace it. So what we do is we take a max between this. Let me do something else. We take a max between this, that is the value without the item and the value with the item. Now, what would be the value with the item? That is, you add the item and you replace the previous one. So the item has value equal to 2, and we will retain that. This is 3, this is 2, this is 5. At 5, we can add both of them simultaneously. That 3 plus 2 is 5. So the net weight will be this plus this equal to 3. Correct? Any confusion?
Yes,
No,
sir.
right?
Sir, why didn't we add the weight in the previous one? Like in the why we didn't add in the item 0 for the item 0? Why didn't we add for the weight 5?
In which row?
Uh, Sir, in zeroth row,
Yeah,
in
in
zeroth
zeroth
row,
row.
item 0, when we are going
Uh-huh.
to weight 5, we are adding
Weight
at the
5.
item 1. We are adding
Yeah.
to 3, but we are not adding for the item 0.
Yeah, because we replaced that. We replaced that. Oh no, wait. In this case, we are taking both of them at the same time, right? So
Yeah.
the weight will be 3 plus 2, 5, and I can hold 5. So I will take both their values, right? I'm taking two items this time.
So, and why we didn't do for the item 0, like for the previous row?
Yeah, in the previous in one row, we only consider that element and everything above it. So the ordering matters in this case. The final answer comes out to be the same, but the order matters in which you take the items. In case we shuffle this weight, this matrix will change, but the final answer would be
Okay.
the same. Yeah, so that's a good point. In a particular row, you only consider the items that you have seen before, not after. So in the first row, this is the first item that we are considering. That is why we can just fill out the values without any consideration. So now let us go further. Now at this point, we were able to add both the items. So obviously we can add both the items after this as well. So 3, 3, and 3. Now the critical point was this. Should I add the particular item, that is replace it? In this cell, when the weight was 4, I had to make a choice between this and this. I think similarly in this case as well, when the weight was 3, I have to make a choice between.
Uh, can I ask something?
Yeah.
Uh, in this, we actually want to store them like in the coding. We have a list. Suppose where we store all the items of different values. So
Mm.
they are you are choosing like that. If we have already two items, which weight is equals to 8, but the value is smaller, and we came across a item which
Mhm,
can also be stored in it. Uh,
mhm,
but the value of some of the larger value item and that item
mhm.
is large. So we
Okay.
want to replace the lesser mini, or we say minimum value item, with that
Mhm.
of maximum value item.
Yes. Yes, that is what
Okay.
we are doing actually. In this case, we have two items. When we go down the line, let's say in a table here or here, we have to make a choice, that is which item should I replace. I could replace multiple items as well if the item is really valuable. Let's say this one had 500. Let's say it has a weight of 5, but it has a value of 600. I should just choose this one and ignore everything else, right? So we will see how to do that. So I think it would be clear in the third row. So let's ignore this for the time being. In the third row, again, when the weight is 0, I cannot pick anything. When the weight is 1, I cannot pick anything. When weight is 2, I can only pick the first element, right? I can pick the first element. Yes, so the value is 1. When the weight is 3, I cannot take the current item. So notice that whenever you can't add the current item, you just take the value above you, right? The value above you says, okay, ignore this row. A row signifies an item. So ignore this item. What is the optimal value for this weight without this item? We already computed it before in the previous row, which is 2. So you just reuse the value. So you see dynamic programming helping here. That is because we computed the optimal value for weight 3, and considering the first two items, when I decide not to take the third item, I already know the answer. I can just reuse 2 here. Understood? Is this part clear? This is important, this part. Does anyone have any confusion here? When your item exceeds the weight of the bag, that is, you cannot add it. You just need to find out the optimal value without the item. Now, not taking the item is essentially going to the previous row, because the previous row has all the items up to that point. And we already know, let's say we did not know this point, I want to find this out. My max weight is 3, my item weight is 4. I cannot add this item. So what is the optimal value without the item given this weight? I already computed that to be 2. So I can just reuse that. Correct? You get this? We cannot proceed if you don't understand this part.
Yes, sir. Till here it is clear.
Okay, so now we come to weight equal to 4. Now we have to make a choice. Okay, should we add this item or ignore the item and use the optimal value without the item? Notice that accepting the item comes with a cost. That is, because it has weight equal to 4, I will have to give up previous items. I will have to remove some items. So what will happen if I accept it? Let's say I accept it. If I accept it, I will gain a value of 5, obviously, correct? I will gain a value of 5, but I will lose the value of items that basically I'm ignoring before that. Okay, correct? Basically, you cannot up to this point, let's say we had a value of 2 and then we gain value 5. Now my new value will not be 7. That is, I will have to ditch 2 or something, correct? So which items will we basically leave out? We have to compute that. So what we will do is the value that I get with by including the item is 5. And now what am I left with? My bag had a capacity of 4, I added 4, so it takes me to this column, the 0th column. Now I have to check the optimal value in this case, right? Do you understand what we are doing? If we do it maybe in this row as well, let's say we had a max weight of 5. I have an item 4. Once I add item 4, I am left with a space of 1. I already know the answers for space 1, correct? So I already know the answers for space 1, and which row will I consider? I will just consider the previous row, that is without that item that we just added. What was the best value at weight 1? That is this and this row. We just have to check this one, and it happens to be 0 in this case. Is that understood? Let me write it somewhere. So what we are doing is we say value with the item is, let's say our table is named DP. So we say go to the previous row, row -1, and the current column. The current column says basically stay in the same weight, but check the previous row, and checking the previous row means ignore the current item. Then we say the value, no, this is value without, sorry. This is value without item. Now, what is the value with the item? The value with the item is basically the value of the current item, obviously, right? And the item is 0. So we take the value, and then we have to take a max actually. We compare between not taking this, that is value without the item, and we compute it. No, wait, sorry. So we have to see the value with the item. The value with the item will be the value that I get, and I add. Basically, what will I do with the left out space? This is the space that the current item consumed. So let's say I had a space of 10. My item has value weight equal to 4. I am left with weight equal to 6. So what is the best way to fill up weight equal to 6? So what I do is in my DP, I go to the previous row. That is, okay, ignore this item. I have already added it. Now in this row, go to column that is corresponding to weight equal to what is left with us. So we go to column minus weight of row. Do you understand this part? Do you understand the semantics of this part? Add the current item. Now with the left out space, what is the best way to fill the rest of the space? Do you get it? It may be a bit difficult, but do you understand? Anyone has a confusion? Okay, those who understood it, can you raise your hand? Okay, someone has a confusion, so let me do it just one more time. In our basically this table, our DP table, a row signifies an item and everything above it. That is, let's say if I am at item equal to 3, I am considering the third item and the items above it, not the items after it. A column signifies the max weight that I can currently hold. So let's say I am at a particular cell and I have to make a decision, should I include this new item, that is the item in this current row. Now, the best case scenario is that I add the item and I keep everything that I had before it. In that case, there is no choice. We just add up the values. But in case we don't have enough space, we have to make a decision. Are the items that are already in the bag more valuable than adding this item? I mean, should I just ignore the item and stay with what I have? Or should I add the new item and throw away some of my previous items in case this is valuable? So that is the choice that we make. Now, how do we make the choice? So the way we make a choice is first we say the, yeah, does anyone have a confusion? You are muted. Yeah, so what we do is, okay. Yeah, Yash, do you have a question? Yash, do you have a question? Maybe not. So what we do is, okay, what is the value if we decide to include the item? If we include the item, we gain its value, but we also take up some space. So notice that the column is the current weight that I can hold. So from the current weight, subtract the weight of the item that I am adding. Okay. Okay, so When we subtract that, we shift to the column of the left out space. That is, we are deciding, this part is deciding what to do with the left out space. If my bag can hold 10 kgs, I added an item with 6 kgs, I am left with 4 kgs. This thing, this highlighted thing tells me what is the optimal way to fill up the rest of the space. Okay. So to fill up the rest of the space, I need to go to the cell which corresponds to that weight. And in that weight, which row should I consider? Just above me, not my current row, because I have already included the item. I cannot use it again. So I just go one row above me. So that is DP row -1. That is, check every item before me and go to the column which corresponds to the left of space. Clear? Do you understand this part now? How we compute value with item? Value without item is simple. That is, we know we are ignoring it. So stay in the same column. We still have the complete space. Just ignore the item. So just go one row up. That's it. And the decision to take or not is basically a max between the two, value with and value without. Any confusion? So Alice, you said you asked me to repeat. So is it clear to you? Okay. So I think, yeah, this is the essence of basically a 0-1 knapsack. So this is how we fill every row. So now let us code this up. Okay. At every basically cell, we only need two items. That is what is above me. That is ignore. I discard the item or I include it. When I include the item, go to the left of space. That is the row. That is the column which signifies the rest of space, and go one row up. So compare this and this. The one which is greater, include that. And in case you have enough space, just add the item. Sum up the row. So let us try our solution. Hold them for the time being. These will come in handy. So we have if underscore name equals underscore main, and let's use the same example. N is 4. The max weight is 8. Weights is equal to this. Values is equal to this. And we will say compute, or just maybe binary KP, binary knapsack. So what do we need? We need the max weight, we need the weights, and we need the values. We can compute the length, or maybe we can also take n as input. And this will return the max profit. We haven't considered how do we know which items to include. That will come later. At the moment, notice that in this cell, once we fill it up, the last cell will hold the final value. Okay, that is when you consider all the items together and the complete weight, the max weight, what is the optimal value? So we basically check last row, last column, that is our answer. Now, which items were included, that is a separate discussion. And let's assume that we are only interested in the max value. So it will return the max profit, which is equal to binary KP. So let's write this up. So we say define binary KP. It takes n, it takes weight, it takes weights, and it takes values. So let's go step by step. What do we do first? We initialize exactly as we did in the Excel sheet. We initialize the TP table with zeros. Let's say initially we fill it up with zeros. Next, what we do is we fill up row 0. Yes, so we fill up row 0. And what did we do after that? Then we went row wise. So iterate over rows. Notice that when we iterate over rows, we skip the first one. No, basically we skip the first row, I believe. Yeah, because this is already done. Yeah. So item 0 is done because we do it manually. So iterate over rows, skip 0th row. Then we iterate over columns. And do we skip 0? I think we can skip this one as well because we know these will be zeros. Yeah, I think we can skip this one as well. So skip 0th. Or maybe not. Let's not skip it. We'll see. So we iterate over the rows, we iterate over the columns, and what do we do then? At any point, we check if we can add the item. Check if item's weight is greater than current weight, current max weight. That is, at every row, at every column, we check can we add the item in the first place? Forget about replacing or anything. Can we even add it? So if we can add it, if yes, or maybe if no, that is easier. If we cannot add it, we simply know to take the value above. Take value above. Else, what do we do then? We compute value excluding the item, which is this other, or, and in fact we should compute value including the item, which is this. Take maximum between them. Did we miss anything? I think that's it, right? And in the end, when all of this is done, we return last item. That is the last item of the table. So let us do this. So how many rows do we have? We have rows equal to n, and we have columns equal to w plus 1. Notice that we have one extra column. So our max weight was 8, but we also have column 0 initial, which signifies 0 weight. So we have columns equal to weight plus 1. So we initialize the DP table and fill, yeah, initialize the DP table. So let's say for row in rows, what do we do? We say DP table is initially a blank list, and we fill it up with DP table dot append empty, fill it up with zeros, 0 for this in columns. Okay, so in every row we add this. So we have a DP table full of zeros. Any confusion up to this point? No, right? Okay, so we got to this point. Now we have to fill up row 0. That is fill up, maybe we should write like this, the 0th row. So in the 0th row, what are we doing? We're basically checking, can I add the item or not? If I cannot add the item, we leave it as 0. Otherwise, we add the value to it. So for I in range columns, what do we do? DP table, the 0th row and the ith column is equal to values I if values I is less than, in fact, or equal to, is less or equal to the current column. I think we should get it like this for call and calls. Is less or equal to column, we do this, else we add 0. So we have initialized row 0. Now we iterate over the rows. So for row in range rows. Now we skip the first one, so let us start at 1. And we iterate over the columns. For column in range, I'm not sure whether we should ignore the first one.
Can I say something?
Yeah,
We also skip the first column because the weight is zero, so nothing is entering the or we placing in the bag.
yeah, that is one thing. But let's say we include it. I mean, will it fill it up itself? That's what I'm thinking.
Uh, what?
I mean, even if we include it, will it fill up during the execution, or should we like leave it? So let's try without it. Let's see what happens. If we need to include it, we'll see.
Excuse me, sir.
Yeah.
Sir, I think that we should include this zero column because, like in the dynamic programming, if we encounter where weight is zero,
Mhm.
so there we will need this column. Like we, like in just in the previous example, we put this
Mhm.
item. So
Mhm.
after putting the item, the remaining weight was zero.
Yeah.
So to include that case, we will require the column number 0.
Yes, but that is already there. We have initialized the full DP table. We are just saying, should we iterate over it or not? It is existent and it is already filled up with zeros.
Yes, sir. That is possible, right?
Yeah. So we're
It
just
is.
saying, should we iterate over it or not? So let's go without it. Let's see what happens.
Yes, sir. That is correct, I think. Okay, sir.
Yeah. So for our own convenience, let's write it here. That is, the item is the row and the weight is the column, so that we don't get confused. So check if the item's weight is greater than the current. So if we have weight of the current item is greater than the weight. If that is the case, in fact, if not, so we will say, yeah, if no, then take value above. So we will say DP table, what is the current row, what is the current column, and we just take the value above us. So we say row -1 and the same column remains. Okay, so that is one thing. Else, compute value without the item, we already know that. So let's say we have value without the item. So we will take DP, we have row -1 and column. So we have DP table and this is value without the item. Now what would be the value with the item? So we have value with item. So that will be equal to values, the value of my current item plus DP table, the previous row, the current column, no, the previous row and column minus my weights item. Let me close this. So we have value with item, value without item. So we had value row, value item, DP row -1, DP row -1, column minus my weight, column minus my weight. Okay. So we have value with item. So we take the max between the two. So we say DP table row column is equal to max between the value without and the value with. Okay, so this is done. And once the entire loop executes, we just return DP table last column, last row, last column. Yeah, so I think this should work. And let's print the table as well. So let's say we say print table, and by we control this here. Let's say we pass it true at the moment. So we have print table by default, we set it to false. So what we will do here is if print table, we say print 1, 2, 3, 4, 5. So we'll write DP table 1, 2, 3, 4, 5, and for row in TP table print row and leave a blank line at the end. And let's see if this works. So we have Python solution 1. Integer is not equal for row and rows. For row and rows, where did we do for row and rows? Yeah. Zero for again. This is not supported. Okay. So we have values column if values column is less or equal to column. Is this correct? Yes. If it is less or equal to column, else yeah. Upper index out of range. Wait. Why are you out of range? Oh, we don't have that many actually. Yeah. So in fact, we are already always checking value 0. We're not checking value column. We are already always checking the 0th element's value. If weight, we add the 0 element's value if its weight is less than the column. Yeah, this is correct. So this is the answer. Let's print it out. So print max profit, and we say max profit, and it comes out to be 8, which I believe is correct. So initially let's print the rest of it as well. So let's say we print the number of items, which is equal to n. We print max weight, or maybe just here we write n, and here we say w. We print out the weights, and we print out the values. Then we get this. So n was 4, weight was 8, and these are the weights. So the max possible will be 8 because we will be considering 3 and 5. 6 and 2 will give us this. So if we go through the table, we had, I think this should look similar to what we have here, right? 1, 2, 2, 3, 3, 3, 3, 3. Yeah, 1, 2, 2, 3, 3, 3. So yeah, this is the same table. So does anyone have any confusion in this? Exactly as we did in Excel, we're just writing it in code. Yeah. So now the question is, how do we find out which items were added to our list? That is, we know the max profit, but what is the item set? What did I steal? So in this table, what we have to do is, first, I mean, maybe think about it for 5 minutes. Can you figure out something? Look at this and see if you can find a trend. The hint is that we are taking this and this. We already know we are taking this 3 and 5. So if you had the table, how would you figure that out? See if you find a trend or something. Take a few minutes. Yeah, take a few minutes.
The row number itself is representing the item number.
Yeah, row 0 is item 0.
Sir, when we are doing the computation at the time, like for the profit for the value 8, we are considering the value with. So considering the value which are coming within the with and which we are rejecting or which we are taking. So which we are taking are coming in with and we are considering them in addition to get the value 8. So I guess through which we can take the value.
So you're saying while computing the DP table,
Yeah,
we
so
should
there
note
this
down
like value with item, value with item.
value with item. Yeah, value with
Yeah.
item.
So here we are taking the values like whatever we are rejecting, we are not considering them. What we are considering, we will take the value item from there.
So let's try that. Let's try that. So let's say we have item set initially blank, and if we end up taking this one, right? So we say
Yes, sir.
if value with item is greater than value without item, I say item set dot append I basically my item, right? Is this correct?
I hope so. Yeah.
Yeah,
Like the
I'm just
finally
asking, is
value.
this what you are saying, right?
Yes, sir.
Yeah,
Like
so
in the end,
so
which value will come in the item
yeah,
set.
so we return this and the item set. So let's see. Yeah, so it says this is the item set. Can you figure out the problem? The thing is the DP table goes through the entire row and it will also compute these values. And sometimes in these values, it will basically include the item, but that may not be part of the final solution. That is, let's say at weight, this I at weight equal to 3, it says, okay, it is better to include the item. And further down, it says, okay, it is better to include the item here as well. So every time we do that computation, it says, okay, include. That may not be the final solution, but that is the solution for that cell. So every time a cell decides to include an item, it will be part of your item set. And that is not the solution, right? Is it clear? The student who suggested it.
Yes, sir.
Okay. So anyone else have any ideas? So let's look at this. So we remove this part and we have remove this part as well. So wait, item set. Let's keep it here. The type back. Okay. So the way to do it is go to the last element or maybe the last row because it contains the entire calculation, that is considering all elements at the same time. What is my max profit? My max profit is 8. Okay, so assume it to be your current profit for this. So the max profit is 8. You will check, is the max profit part of this row? Okay, so we say, did I get it in this row or not? If it is not in that row, obviously this item did not get me to this point, correct? Because if the inclusion of certain item made you basically got you to a particular profit, it will be part of that row, correct? For example, 8 is part of the last row because inclusion of the last item gave me 8, correct? The other thing to note is it part of the row above me as well? For example, we see this 2 is here, 2 is here. Okay, so which one was who was the actual contributor of this 2. So for any value, let's say for 8, the yeah, so the contributor of a profit is an element that is, if the profit is part of the row and it is not part of the row above it, that is, we find out the contributor by checking the current row and the row above it. So let's say we get to profit equal to 8 and we have item 0, 1, 2, 3. We check item 3. Is 8 part of it? Yes. Is 8 part of the row above it? No. That means that 8 came up by the inclusion of element 4. Okay. But the element 4 had value 0, 1, 2, 0, 1, 2, 3. Its value was 6. So it did not contribute the entire profit. It contributed 6 out of it. So what am I left with? 8 minus 2, right? 8 minus 6, which is 2. So I'm left with 2. So we go here and we see, is 2 part of this row? Yes, 2 is part of this row. So am I the contributor? But no, the row above me also has 2. So he may also have contributed it. So I am not the contributor. I go to the row above me and I check, does this contain 2? Yes, it contains 2. Does the row above it contain 2? No, it does not contain 2. That means I am the contributor of this profit 2. So then I also know that is my current profit for 2 and I am the contributor. So what was my value? So 0 and 1, my value is 2. So 2 minus 2 is 0. And now we don't have any profit. There is no need to check above it. So do you understand how to do it? Go row wise, check the current row and the row above you. What is the semantics behind it? I mean, if I have contributed it, the jump in the profit should be in my row and it should not be in the row above me. Otherwise, that may be the contributor and we will have to check that as well. Clear? Those who get it, can you raise your hand?
Excuse me, sir.
Yeah.
Sir, are multiple solution also possible?
For an abstract problem.
Yes, sir. I mean, if there are 2 items
Mhm.
which can come in the solution, mean 2 solutions.
Yeah, so they
Could
will
we-
be equivalent solutions. Yeah, so I think it will probably depend in the order in which you build up the table.
Yes, sir.
Yeah, and think about it. I mean, if you are a thief, you only care about the net profit. You don't care about the individual items.
Okay, sir. So I think it can have multiple solutions. So there is not a uniqueness in the solution. So according to the order, we may get different number of items in that.
No, I think the number of items will remain the same. Which item you took, that may change. I mean, there will be 2 items which will be identical probably. That would be the only thing that would be missing. That is not the identical item, but probably the weight and the value will be the same.
Yes, sir. Okay.
The number of
Uh,
items will be the same and their individual values will be the same, but it just won't be the same item.
but as if in the problem you have already said that you cannot add one item twice. Means
Yeah, you cannot add twice.
so
Yeah.
it means that all items are unique in the
Yes.
sense.
No,
So I
I
think
mean unique in the sense, for example, let's say your items are like this. You have 3 items. Everyone has weight 1, 1, and 1. And everyone has value 10, 10, and 10. So these are the same in value, but they are, I mean, 3 different entities. If we look at it, this is item 0, this is item 1, this is item 2. They happen to have the same value and the same weight. So let's say I asked you to compute the solution. In this case, there will be 3 solutions probably, or maybe 2 solutions. But which 2 did it choose? It would depend on the ordering of this. That is, did I set this to 0, this to 0, or this to 0? Do you understand now? Let's say the middle one was 2. So
yes,
now 0 and 2 are identical, but they are, I mean, you understand the index is different.
yes, sir.
Yeah. So
Okay, sir.
Yeah. So that is what I meant, that the order will matter in that case. That is, you
Okay,
may
sir.
see when we print out the indices may differ, but the values and weights will be the same. So
Sir,
let's.
can it be that weight is not same but value is same?
No, I don't
Weight
think
is
so. No.
not same but value is same because we have a total
No, but
maximum.
then one of them is more profitable than the other.
No, I'm saying that value is same. No, both of them value as same, but
Yes, both have
weight.
the same value. Then I will pick up the lighter object, right? Why will I pick up the heavier object? I have more space then.
Okay, sir.
Yeah, so let us print the table now. No, basically track the items. So find the items in the knapsack. So how do we do it? We start at the last row. So for row in range rows, and yeah, it includes the last one, and we go up to this. Basically, we are coming from 0, basically from -1 all the way to 0. For example, in our table, we start here and we check this. We don't check the last one because we will run into an error, because it will check for a row above it and we won't find it. So we will stop our for loop here, and this one we will do manually. So for rows, we start here and it will stop at 1 because we know the for loop stops at 1 step ahead. So we have 0 and -1. So that is, we are doing it in reverse order. So what do we do in each row? We have to find the profit. So let's say current profit is equal to, let's store it here. So let's say we have max profit is equal to TP table -1 -1. That is the last. Okay. So we say the current profit is the max profit. And for every row in this, what do we see? We say if current profit in TP table row and current profit not in TP table row -1, that is, I am in the row and not in the row above me, then we add it to the item set, that is item set dot append row. Row is the item, right? Item is row. So we can also do this. So we append the item, and there is no need, I think, yeah, for row, and we go, yeah, this is it, yeah. And what do we do after that? I think there is one more thing. Yeah, there is no need to iterate if the current profit is 0. So if current profit is equal to 0, we break. There is no need to continue the for loop. And then we check the 0th row manually. So if all of this basically, and there is nothing above me, so we don't need the and we already know the row is 0. So if current profit in, also we have to check the gain, yeah. So if current profit is greater than 0 and the current profit is in this thing, so we say item set dot append 0, because we know it is the 0th item, and then we return the item set. Let's see if this works. In DP table row. Okay, so the rows. We start with rows with 0. It is in, if current profit and current profit no row -1, line 55, line 55. So what did we do? For row in range rows. Oh, yeah, rows -1 maybe, because no, we're doing something wrong. So rows -1, because in our case rows is equal to n, so we have the last row will be n-1. So yeah, so we will start with row -1 and we stop one step before it. So if current profit is 0, we break, which is not the case, which is max profit. We say the item is equal to the row. If current profit in DP table row, so what is the problem here? So let's debug this maybe. Run, start debugging. Okay, so we're here. Row is 3, 0, 1, 2, 3, which is correct. Item equals row. So what is the problem with DP table row? We have DP table row prints out. Row -1 also prints out. So this iteration does not create any problem. So we have 1. Let us watch this one. We don't want this, we don't want this. The row is 2, row is 1, and now we should exit. Right, and did it throw an error? No. We're getting the wrong answer. It says item 3, so 0, 1, 2, and 3. And it says the profit is 8, so it is ignoring this one. It's ignoring this one. Why? Why are you ignoring this one? So 0 and 1, you should come to 1. And if profit is not in the previous row, which is correct, so you should append it. Does anyone see any problem? So the row is 2. Now the row is 1. And if we print this, the row is this, and the row above me is this. So this should go ahead. What is the current profit? Oh, we did not recompute current profit. Yeah, that is the problem. So once we find this out, that is, we append the item, we should subtract current profit. So current profit is equal to current profit minus the value of the current item. Yeah, so this will update current profit. Let's run it now. So it says item 3 and item 1. So let's return it in reverse order. Reverse item set for convenience. So item set is equal to item set this, and if we run it now, we get item 1 and item 3. So 0 and 1 and 3. So if we print this out in a better fashion, so let's say we have this for item in item set, we say print item I, and we print its weight is weights I, and we print its value, which is values I. And now we open. So is it the correct answer? Item 1, W3, W2, W3, W2, weight 5, weight 6. Yeah, correct. So we have half an hour for the second problem. So does anyone have any confusion with binary knapsack 0, 1? Yeah, Karan, you have your hand raised. Okay, so moving on to the second one. It is a variation of the binary knapsack. It's called the unbounded knapsack. In this case, you have an infinite supply of every item. Okay. Up to this point, everything is the same. The task is to put items into the bag and find this. we can add an item as many times as possible. That is, in the previous case, I had only one copy of every item. That is, item 0, I have one of it. Item 2, I have one of it. Item 3, I have one of it. In this case, I have an infinite supply of everything. Let's say you have entered a mine and there is coal, there is silver, there is gold, and you can take as much as you want. Okay. So at every point, you have to decide how many times should I take this item. So this is a slightly more complex problem, but I mean, the beauty is that you have to change very small thing in your code for binary knapsack to achieve this thing. So see if you can solve this one, unbounded knapsack. Is the problem clear? Is unbounded
Yes, sir.
knapsack clear? Yeah. So try it out. Maybe I think only 5 minutes because I'll have to explain it. We don't have enough time. Yeah. So notice that this is the same problem as before, 2, 3, 4, 5, 1, 2, 5, 6, but this time the profit is 10. Previously, the profit was 8 because it was considering this item and this item. In this case, it takes item 2 twice. 0, 1, 2, it takes this item twice, getting a profit of 10.
We can do like that if the weight of the last item which we are adding is actually have a larger value, and totally divide the weight total weight which was been carrying by the bag. So we add that item, uh, that how much times it like quotient of the when we divide the weight of the bag by that item, uh, at that we add that items according to the quotient of that, and then search for less value items or less weight items like you do.
So there will be a much simpler solution actually. Think about the table. The initialization would change this time. Forget about the whole solution. Think about how will you initialize row 0. When we were doing binary knapsack, we filled up row 0 by just checking, can I add the item? How will the initialization of row 0 change? Figure that out. See if you can figure that out. If anyone gets it, I mean, unmute and please answer. Only row 0. You're considering item 0 and increasing max weight. How will you initialize row 0?
Sir, by writing the quotient,
By writing
means quotient and then multiplying it by that value.
quotient of what?
Uh, Division of the weight by the value of the 0th item.
So the quotient, okay, so basically only integer part, right?
Yes, sir. Only integer part. Only integer quotient.
Yeah, and multiply that with?
I multiply it with by the value of that item, so it will give me the maximum profit value.
Exactly, exactly. So the idea for the initialization is, let's copy this table here. So previously we decided that okay, with weight 2 we can add it and afterwards we can add it again and again, right? In this case what happens is let's make them 0 0 0. So my weight is 2, I cannot add it here, I cannot add it here, I can add it here, okay. With weight 3 again I can add it here. With weight 4 I can add this twice, right? 1 2, and therefore I will get the value twice as well, so 2. So what Yash suggested, why isn't it right? I think the font is white. Yeah, so what he suggested was take the current weight, let me write it here maybe. Take the current max weight, integer divided by weight of item, okay, by the weight of the item, and multiply this entire thing by the value of the item. So the first part tells you how many times can I repeat my item while I satisfy the weight constraint. And let's say this comes out to be 1, I multiply it by 1. If it comes out to be 2, that means I can take the item twice and I multiply my value with that. So that is the initialization of row 0. So that part is done. So that is the essential part of DP, the first stage. So let's say this will be 2, this will again be 2, I believe. This time it will be 2 is 3, 3, yeah, we will get 3 here, then 3 here, and 4 here, yeah. So notice the difference, 1 1 1 1 1, but in this case we have 1 1 2 and so on. Now you go to row 2 or any other row, so think about how will the solution change. It is very close to the solution of binary knapsack. There is only one change probably, yeah.
Okay, so can we do like that? How many times in the last element we add the last item, and then it check in the first row that how many times the first item which should be added, and if until that point our bag weight don't reach the limit, then we check uh, further uh, again in the next row how many times we add the next item, and iterate it over until the weight of the bag don't reach its limit.
Yeah, so Shivam, I think you've just joined the session. We should probably leave also. Yeah, so it won't require that many iterations. So let's go to this point. Do we still have it in problem 1? No, we deleted that. So we had this thing, right? For problem 2, let's see if this works. So if we discard the first thing is if I cannot add the item at this point, I again have a choice. This is more difficult. That is, if the weight increases, I have to decide, can I reuse my previous items, right? So how can you do that? You already have the answer right above you. That is the same weight, excluding this item. The row above you will already contain that solution somehow. In DP, you don't have to think about how. Basically, the row above you contains the answer for that. That is, with increased weight and considering this many rows, what is the optimal value? That is, it will already know, okay, should I repeat it this many times or not, or so on. The next thing is, if I decide to include the item, okay, I have to obviously, previously, remember that what we used to do is we used to go to the previous row and then think about the left out space, correct? In this case, the only difference is that I need not go to the previous row because I am also considering the current item. So the only change is within the same row, go to the column corresponding to the left out space. That is the only change. Does that make sense? In binary knapsack, we said, okay, if we have included the item, I can no longer use it. So go to the previous row. Now go to the column corresponding to the left out space. In this case, we say, okay, I have added the item, but I may add it again. So let me, within the same row, let me go to the column corresponding to the left out space. Does that make sense? Okay, so people who understood it, can you raise your hand?
Excuse me, sir.
Yeah.
Sir, this step is clear, but how will it solve the question that is not clear? Means how will it answer this problem?
Yeah, so the point is, I mean, the confusion might be that how does it know which item to repeat or not? The thing is, this cell, once it is filled, it has already used prior knowledge to fill it. That is, should I repeat it or not repeat it? So when the first row is filled, when we get to the second row, by filling the second row, it will compute between this and this. Okay, should I repeat or not? Okay, at any point. Let's say we try to fill it ourselves. So with weight 0, we can't fill anything. With weight 1, we can't fill anything. With weight 2, can I add anything? Yeah, I can add the first element once, right? So it is equal to 1. So if we try to apply the formula, that is what would happen if I in fact, can I add it? Yeah, I cannot add it, so I can just take the one above me. So this is simple. Now the weight is 3. Now I have to make a decision. So should I take this item? Should I take the previous item? Can I repeat something? So the first thing is, okay, don't take the current item. What is the value above me? The value above me says with the current weight, how many times can I add item number, an item 0? And it also includes how many times should I repeat it? Because I mean, I think you yourself gave the solution. That is, the row 0 already contains the multiples. That is, take this item this many times. So we
Yes, sir.
already, yeah. So I think we were in which this row, yeah, 3. So we already know that we can take it once in this case. And the other option is that, okay, within this, the answer is this, my current value, and what would happen with the left out space. So my current value is 3, and if my current value is 2, and if I include it, I am left with no space. That is 0. So I will compare 2 and 1, and the answer would be 2 in this case. Clear up to this point?
Yes, sir.
Yeah.
Yes, sir.
Now we get to 4. Now we get to 4. So now we have an option here that should I include item 2 or should I do something with the remaining items? And notice that the remaining item already contains multiple. That is, okay, use this one twice. So do you see the power of dynamic programming? The earlier solutions have already computed how many times a particular solution should be included. So we come to this and we compare between the value 2 and this one, that is weight equal to 3 and this 2, the value of 2. So I think in this case, in fact, the weight here would be 4 and the weight in this case is 3. So this is probably the better solution, 3 in this case. But we only can take max between the values, right? So we can either take 2 of those or we can take 1 of this. And when we take the max, we take the max among the values. We don't know the weight, right? So the value without the item would be dp rho minus 1, and the value would be my value plus what am I adding? So what am I adding in this case? I am adding nothing. So yeah, in this case, the value would come out to be 2. Yeah, so how does it matter? The value is identical. Yeah. So now we come to 3. Can you repeat this item? No. So again, the answer would be 2. In this case, I can repeat both of them. I can either repeat this part or I can repeat this part. Okay. So let's see what happens here. So if I decide not to take this item, I will take the item above me. And how many times will I take it? I will take it thrice. 3, 2 is 6. Okay. The other option is I take the item. So if I decide to take the item, I will take the item and its value equal to 2. How much space am I left with? I am left with 3 space. So in the same row, go to this part And in this part, it said, okay, it is better to take the previous item rather than taking your own item. And if, I mean, we can fill the entire row, but if you see that at some point we will basically hit a cell and we will have to check one of the previous cells, which would have computed that, okay, I should use this item multiple times. So Yash, is that clear? You see how it works? While we traverse the table, we are implicitly computing how many times should an item be repeated. Because think about it. In this case, it just happened that, for example, in this cell, I mean, in cell 6, I had the choice to repeat. I mean, I can't. Yeah, in this cell, I believe. Yeah, in cell 6, I can repeat item this twice, which would give me 4. Okay, and the other thing is I can do this. So let's say I decide to exclude it. I get a value of 3. The other option was to include it, and I would get a value of 2. When I get a value of 2, the remaining space is 6 minus 3, which is equal to 3. So I get here, and again the value is 2. So I add it, I get the option of 4, and the other option is uh, was 3. So notice that I have taken this item twice now because I used this row twice. The first time I used it was when I used its value 2. The second time I used it was when I preferred this cell over this cell. So 2 plus 2 made 4. So that made it repeat item this twice. Is it clear?
Yes, sir.
Yeah. So in this way, it knows how many times to repeat a particular item. If it sees that the value above me, which already has the information of the repetitions, if it says that in my row itself, I can do better, that essentially say that I am repeating myself. By staying in my row, I am saying repeat myself. So let us make this change and see if we can compute it. So we have to use the same code for binary. So we have solution 2.py. So we had this, and instead of binary KP, we'll say unbounded KP. So what changed? The initialization changed. Fill up 0th row. So how do we fill up 0th row? We say the current column integer division by my weight multiplied by my value. So this is how we initialize those 0. The iteration is same. If the weight is greater, this is the part which changes the value with the item. So in the value with the item, we don't go to the previous row, we stay in our own row. And this part is identical. This is same. This will change. Finding the item will change. So let's comment this out for the time being. Yeah, so it was 10 with just one change. With 2 changes. So the way you initialize row 0, and that instead of checking the row above you, check the row within you. And notice that this one change in code, that is checking my own row, contains the entire semantic that, okay, I am considering my own repetitions. So we have unbounded KP, so and so. Now remains the problem of this. How do we find out this? So let's print out our DP. Are we printing that out? Yeah, we are printing that out. So let's say our profit was 10. So assume that we did the same thing. That is, we checked if the element is in this row and the row above me. So we see 10, 10 is this row, 10 is also in the previous row, ignore this row. So we get to this row and we see 10 is here, 10 is not above me. So this item was used. Okay. And then we exit the row. That is, we don't check it again. But notice that we were allowed repetitions, that an item may have been used again. So should we leave the row or should we check the row again? What do you think? And if we have to recheck the row, how many times should I recheck the row? Any idea? It's the same concept. You take the profit, you subtract, you check the new profit. I'm just asking how many times should I do it in a single row because repetition is allowed. Okay, what is the criteria for in our previous case in binary knapsack? When did we exit the row? When we found out that okay, this profit is no longer here, right? So we do the same thing here. That is check 10. 10 is not here. Forget about this row. Check this row. 10 is here. 10 is not above me. So this is the contributor. How much did it contribute? It contributed 6. So what remains? 4. Now check for 4 in the same row. Did this item contribute for 4 also? If it is not present, then exit the row. Otherwise, keep on going. That is, we enter an infinite loop over a row and we keep on checking again and again, is the new profit contributed by this element, and we the infinite loop is broken when either the gain, that is the profit, becomes 0 or we don't find the profit in the current row. Clear? Make sense? Can you raise your hands if you understand? It's the exact same concept. I'm just checking multiple times in the same row rather than exiting by checking once.
Sir, please repeat once more.
Okay. So in binary knapsack, what we used to do was go to a row. What is your current profit? Check if that row contains it and the row above you does not contain it. If that is the case, you are done and you make one check in either case. It is present, good. It is not present, that is also fine. You check the next row. In this case, we cannot leave a row by checking only once because repetition is allowed. So what we do is we make a check. If I don't find the profit, that's it. I won't find the profit anyway. So let me go to the row above me. If I do find the profit, what do? We do this computation, that is current profit. Current profit is equal to current profit minus my value, right? Value of item. Now this becomes my new profit. I should recheck this in the same row because it may be the case that this very item, because it has been used multiple times, it may have been used multiple times, he may be the contributor of the new profit as well. So I should check infinite times in the same row until I don't find the profit in my row. Make sense?
Okay, sir. Yes.
Anyone else? Can you raise your hand if you understand it? I usually see just 2-3 hands. So Anos, did you understand it? Did you get it?
Oh, sorry, I joined late. I'm a student of this course itself. So, would this recording be available to us?
Yes. Yeah. I'll basically, I think you did not attend the previous session, so I'll let you know at the end of the session. Yeah.
Yeah, sure. I'll just go through it because I'm a working professional. I don't get time.
Yeah, no issues. No issue.
Yeah. Thank you.
Yeah, so let's change the code here. Okay, so we have solution 2. This remain, where is it? Yeah, so this is the part which prints the, no, this is the part that finds the item set. So let's uncomment this. So the current profit is max profit. For my row, obviously we first check that is the profit is non-zero, and then we say item is equal to row. And what do we do then? We say while current profit in PP table row. Okay. I think this is enough. Yeah. So we basically say keep on checking the current row as long as the current profit is in the row. And within the while loop, we are updating current profit. So this one change is the semantics. That is, check the loop infinite times if you see current profit infinite times. And at some point, one of two things will happen. Either the profit won't be in the row or the current profit will become zero. Yeah, in fact, we should maybe do that as well. While current profit is greater than zero and current profit in this, yeah, we should do two things because it may happen that we hit zero and we don't have it in the row. I think that may be possible. Yeah. So we have this, and we have to do this while thing here as well. So we have while current profit is greater than zero, and instead of row we say zero here. And if current profit is greater than zero and current profit in DP table zero, item set dot append one. Yeah, I think this is it. So let's write this here. Separate case for row zero. So let's see if we. Oh, it's gets stuck in an infinite loop. Something. Oh, we did not write break. Oh, it does it is. So if while current profit is greater than zero and current profit is in DP row, what do you do? If current profit, wait, do we need an if? Yeah, if we don't need an if, right? So yeah, we don't need an if clause, I believe. But do we? I think we do it in this part only. Yeah, we can, I think, do it here as well. We don't use this. That is, while the profit is greater than zero and the profit is in the row and the profit is not in the row above me, add it to the item set and update current profit, right? Update current profit. So this keeps on happening. And then what happens? Item is equal to row, which is correct. And the same thing can be done here as well. That is, current profit is greater than zero, current profit, and not in above will not be a case. So I think this if is not needed. So we say this should work. Something's wrong. Something's wrong. Let's debug this. So for row in this, if the current profit is zero, which is not the case, my item is row. While the current profit is greater than zero, which is the case, and the current profit is in DP and not in DP this, I don't go over this, right? Yeah, we go to the row above us, so which is this row. Now what happens? If the profit is zero, which is not the case, my item is my row, and in this case, our DP table row looks like this, and our current profit is 10. So it is part of it, and row minus 1 does not have 10. So we should enter the while loop, right? So we enter the while loop, okay. We add item set. So we have a VDD, where is I? Is item set. So we have item set dot append item. We have item set, we add 2 to it, okay. And then we say current profit is profit minus values of the item. So is current profit different now? Current profit is now 5. And the current profit is greater than 0. And it is still in here, and it is above it as well. So we should not enter the while loop. It did not enter the while loop, okay. So we are at row 1, that is the last row. And we see if the profit is 0, which is not the case, row becomes this. So what is DP table 0? So we have DP table 0 is this, 5 is not in that, so we should enter this while loop and we edit it. Item set becomes this, and then we get current profit. So what will be current profit? So the current, oops, current profit is 1, and 1 is greater than 0. 1 is greater than 0, 1 is in here and 1 is in here. So now I come here for rows in range. I mean, shouldn't I end? Yeah, okay, so this is where the problem is. This is working okay. Oh, we're not updating current profit. That is the issue. We're not updating it in 0 case because we're not expecting it in the binary case because we check and we leave. So if we stop and we go to the terminal, we don't need this, we don't need this. So we have Python solution 2. It says, and this looks wrong. I think we should have used this twice, right? This looks wrong. It says use this. So 2 and 2 is 4, 4 is 8, and 3 is 11. So this is wrong. Yeah, this is wrong. But the max profit is coming out 10. So I think the tracking is incorrect, but the profit computation is correct. So we are making a mistake here somewhere. So for row in range, this, if the current profit is 0, there is no need to continue. Then we say item is row, while the current profit is non-zero, and the current profit is in this row and not in the row above you, you add it to the item set. Which items did it add to the item set? It says add item 2, but it did not add item 2 again. So that is in itself a mistake. It should have added item 2 twice, which it did not do. Current profit, in DB, current profit not in DB table -1. We do this and this. And we run it over all the rows. There is some problem in this for loop here. Does anyone see any issues? The logic seems correct to me. But the profit is non-zero, and the profit is in the current table, and the current profit is not in the table above you. Wait. Current profit. Okay, so will it check it twice? Let's say I get a profit and there is no break statement, right? There is no break statement. What is my break statement when this fails? Is correct, and current profit should update. So what is wrong? So this is the first case when our current profit is 10. So we don't enter. Yeah, we don't enter this time. So we enter this with this and we get current profit is 5. We should re-enter this, right? We should re-enter it because we have 5, but we have 5 here as well. Something is wrong. Should we have 5 here? Because if we want to use it twice, then 5 should not be here. Yeah, 5. I think this is okay. There is something wrong above. DP table itself is incorrect, I believe. Yeah, it's 7 o'clock. So if any one of you wants to leave, you can leave. I'll finish debugging it and then push it to GitHub. So for people who are new here, you will find the code at this repository. Let me share it with you.
So can you kindly share the recording also?
Yeah, I'll give you both. I'll give you both.
Thank you so much, sir. Just please share the GitHub code. I'm new, actually. I mean, I just joined today. Unfortunately, I didn't get time. So
Yeah, no issues.
any other like references or like any other important YouTube links you can just share.
No, I think I don't know how the professor will evaluate you, but I think if he evaluates from his material, that should be enough. I don't think you need anything else. The sessions were more of a hands-on thing. That is how do you do it in practice? What is efficient, what is not.
Yeah, sure. Yeah. I was just, I mean, I was just asking about that only. Like, if we have any references for this. I mean, whatever you have actually taught or whatever you have practiced in the previous sessions, if you can share anything, that would be good.
No, I mean, I did not take it from a book. Actually, I think of problems a few days before the sessions and I try to, go up incrementally in complexity. This is the naive solution. What would have been better? What would have been even better? So it's just from experience. I did not follow a book for it.
Okay. So it's all the live sessions you have shared, right? In the YouTube.
Yeah, it's in the live sessions and they are timestamped, so you can jump around. So I think if you want to do that, it is okay. Yeah. So can you
I'll
access
go
these
through.
two links?
Just a second. Let me check. Just give me a second, sir. Let me open it up.
No issues.
By the way, myself Wazir. So I'm in this course for the second time. The first time I did it in 2018 or 19. At that point of time, this was not there. So I had to brush up the things. So I did this course again.
Okay.
And this course, I felt this course was very good. At that point of time, also I was facing some issues with the programming assignments. So I thought to do it once again.
No.
Anyways, let me just check and tell you.
Sir, I have a question. What type of question answer will come in examination? MCQs only, or we have to make coding exams?
Yeah, you're not clear, but I think you're asking something about MCQ or something. So I'm not aware of the exam format. So the people who teach the course and the people who take the sessions, we are completely out of sync. I mean, we don't communicate with each other. So I don't know what they will ask.
The examination will be general. That will be the only MCQ based, or we have to create the kind of program or something.
Can you write it in the chat? Your voice is very feeble. I can barely hear you. This 4, 3, 2, 2, 4, 3, 7 to 9, 11. So this is wrong.
Yes, I can access. Thanks a lot. I'll leave now. Thank you. It was very nice interacting with you.
Yeah.
Although it was a very short interaction.
Okay.
Thank you, sir. And please, I mean, you'll add this recording also, right?
Yeah, this recording too, I will add. Yeah.
Okay. Thank you so much, sir. So in the same YouTube link only, correct?
Yeah, 7 of them are there. I'll upload this 8th one there as well.
Thank you. Thank you, sir. Thanks.
Yeah.
Nice talking. Bye-bye. Have a nice day.
Okay. Bye.
Sir, good evening, sir. Can you suggest any book for this particular topic, sir, other than your lecture, especially for this program, this problem?
Dynamic programming?
This problem, sir, whatever you have explained.
Knapsack.
Any reference textbook for this one?
You will find plenty of material for knapsack online. I mean, just do a YouTube search. So you'll find plenty of people doing knapsack. I mean, for binary knapsack, this is a good video from Abdul Bari. He has a good video on binary knapsack, but I don't think he does unbounded knapsack.
So one last thing. So can you suggest any good book on dynamic programming?
On dynamic programming alone?
Yeah, and memoization.
Yeah, I'll have to check. I mean, I have a friend. He's in theory, so he knows these things. That is, which book is good for what. I did not study it from a book myself. So if you want a book, I can ask him for that. So you have a forum for this, or maybe from the GitHub you can access my email or something. Mail me and I'll ask him, and then I'll get back to you. If any of you wants any material in this case, it's better that I'll ask him.
Sure, okay, sir. And any other links where we can practice?
Yeah, for practice, there's plenty. There is lead code. There is, I mean, data camp or something. What was it? Data camp, I believe. Yeah, there is data camp. There was Hacker Earth.
Okay, hacker rank, lead code, and these all things are good enough, right, for practice?
Yeah.
Okay. Okay,
Yeah,
all right,
so I
so
think,
I'll email you for any
okay.
book.
Yeah.
Thank you.
So I think we'll end the session here. This is the last session.
Sir, what is the application of particular concept, sir? What is the
Dynamic
application?
programming.
Yes, sir. This type.
I mean, this one, a knapsack.
Yes, sir.
I mean, you can extend knapsack to other problems. For example, there is a problem known as rod cutting. It is the exact same thing as knapsack. So when you see a new problem, you have to basically connect it to a problem that you know. Many times complex problems are just a simple problem with a different name. So if you see a problem, okay, this is similar to knapsack, so you can apply the idea of knapsack to it. And knapsack itself is dynamic programming. So whenever people teach dynamic programming, they usually start with knapsack because this is the go-to problem for dynamic programming.
Okay, sir.
Okay, so I was saying this is the last session. So I wish you all the best for your futures. And I hope the sessions were good. I learned a few new things. You people also, I mean, I hope these were useful for you as well.
Sir,
So,
we all got to learn a lot of things from you.
yeah,
New
thanks.
and complicated programs, how to deal with. We got a good experience with your lectures, sir. Thank you, sir.
Yeah, it's good to
And,
good.
so the best thing which I liked is that from your lectures I learned that how the professional programming is done. Means like you used that if definition, name is equal to main, those things, and like debug mode, and several even in the whole of the lectures you didn't even use any notebook. So all of your lectures were based on only this comments. Means you explained the whole program by just typing the concepts in the comments, and that was just really very beautiful. So
yeah, thank you. Yeah, I believe that is actually better because when I learned it, I also learned it from Jupyter notebooks, and then you suddenly see a jump when other people are doing it in scripts and not, and you don't know how to go from this to this.
yes, sir, it was a very good experience, and we also wish you a very successful life and career.
Yeah, thank you.
So by the way, you are working somewhere, sir?
No, I'm doing my PhD.
You're doing your PhD in you're in computer science only?
Yeah,
doing your PhD. Okay. And you've already done your master's, MTech, or
No,
like
I
you
did
came
not
from,
do my. I directly joined after my bachelor's.
okay, so you are a BTech.
No, I'm not a BTech student. I have completed my BTech. Now I'm doing my PhD.
Yeah, I was saying that you completed your BTech earlier.
Yeah.
Okay. So is it possible to do a PhD after directly after completing a BTech?
Yes. Yes. Nowadays they allow it because I mean, if you are already decided that you want to do a PhD, there is no point in wasting 2 years in between. If you already know you want to go for a PhD, if you directly apply for a PhD, you have to do a little more coursework than people who join after doing their masters. Basically, that is the only difference.
So did you appear for any entrance like GATE, or you directly went for the coursework?
I mean, it was a long process, so there were interviews and so on. So it was a very unique journey. So maybe we'll talk about it some other day.
All right, sure, sir. Anyways, I missed out on the sessions, but I'll listen to the recording. Thanks a lot, sir.
Yeah, no issue.
Thank you.
No.
Thank you. Have a nice day and a great future ahead. Great career. Wish you
Yeah,
all the
you
best
too.
for your
You as
future.
well. Yeah, you as well. Yeah, Nazia, you were saying something.
Yes, sir. Actually, next week we have a final assignment, means assessment exams. So, do you have any idea how this one process will go on? Like my HOD had told me, like one day before we'll be having programming test, and on the day of exam we'll be having some MCQs, whatever the assignment we had done in NPTEL. So, sort of that will be there on that particular date because 24th is the exam day. So, I just want to like get a little bit clarification regarding that.
Yeah, I'm not sure how you will be graded. I have no idea what your exam pattern will be.
Okay, no, because it's a programming course, no. So rather than other courses, it will be like MCQs on the same day. But for programming course, one day before they'll give some programming this one. So after that, we'll be having a MCQs test. So like that,
I mean,
I want.
maybe you can do you have access to that forum? There is a forum for this course. If you ask there, I think there are TAs related to the lecture material. They can answer you.
Okay, okay, sure, sir. Okay, thank
Yeah,
you, sir.
I think they are active on the group.
Okay, sir. Thank you, sir. Thank you so much.
Okay. Okay, so I'll stop recording.